Okay, so now that we have our data open, just as a reminder, we're looking at whether anxiety is reduced after having cognitive behavioral therapy compared to a waitlist control group. So our treatment variable in this data set is where we identify whether somebody received cognitive behavioral therapy or the waitlist control. One quick thing that you can note is that in SPSS, if you want to see the value labels that you've created for your variables, if you click on value labels, suddenly if I've applied a label to the 1s and the 2s, I can see those labels instead of the numbers. I personally find this a little distracting, but it may be helpful if you have a lot of variables where it's hard to remember what they were labeled as. So for now, I'm going to turn that back off, but it's good to know that it exists. All right, so now I'm back to 1s and 2s. We're interested in the anxiety at the end of treatment, which is labeled as anxiety post. Briefly, let me take us back to variable view and remind us what we've already learned, which is that when we have a nominal variable, such as the treatment condition, it's nominal because the variable represents a group or category. You're either in cognitive behavioral therapy or you're in the waitlist control. In this case, the numbers don't really mean anything. I could label them with a 1 or a 100 or a 1000, and it really wouldn't make any difference in my analysis. The 1 is just simply a placeholder for the text. I've labeled my values so that I can remember which one is which. In this case, 1 is CBT and 2 is waitlist control. I've also labeled the type of variable. This will be useful when we make graphs. So I've labeled this variable as nominal, and as a reminder, it's visually just these categories. So you might imagine, for example, the little red bubble is the people in the CBT group, and the green bubble is the people who are in the control group. Our anxiety post score, because it's a mean score on a 1 to 10 scale, represents a scale variable, meaning that the difference between 1 and 2 and 2 and 3 and 3 and 4, all of the intervals is assumed to be the same. This allows us to choose an independent samples t-test as our analysis. So let's take a quick look at how we would do that. First, I'm going to analyze, and one of the assumptions of the independent samples t-test is that the data needs to be roughly normally distributed. So I'm going to first go to descriptives and frequencies to evaluate the assumption that it's normally distributed. I'm interested in the post-treatment anxiety score, and I'm going to choose charts. I need a histogram with a normal curve laid over top. When I hit continue and OK, now I'll see what it was I was looking for, which is generally a normally distributed curve. You might say that it's not perfect, but it certainly isn't, for example, bifurcated where you have two completely separate peaks at two different points. We see there's roughly a centering here. More people are between the 2 and 6 than anywhere other place, and that we have enough of a normally distributed curve to go ahead and assume that our t-test will work. So now that we know that, we're going to compare means and choose an independent samples t-test. Once I've done that, I'll see two options come up in front of me. I see the test variable and the grouping variable. In thinking about the independent samples t-test, we know that we have a group that is identified by whether you receive the treatment group or the control group. So thinking about that, we know that we want to put our treatment condition into the grouping variable. And once I've done that, then this option to define groups will suddenly become available. What this means is it wants me to know what number I've assigned to each of the groups. Remember when I said that the numbers don't matter in the nominal variables? They don't. So I just simply need to list what number did I assign to each of the groups I want to compare. And remember that we wanted to compare a group that was labeled as 1 and a group that was labeled as 2. Now, if I had labeled them as 0 and 1 in my data set, then in defined groups, I would make sure to put 0 and 1 instead of 1 and 2. In the test variables, we're testing the differences in our outcome. And our outcome in this case is post-treatment anxiety. So as a general rule for independent samples t-test, your scale variable will always be your test variable. Your nominal variable will always be your grouping variable. It's very simple to put those two things in, and then now we can just hit OK and see what happens. So in my output file, I now see two pieces of information in the t-test. I see group statistics and the independent samples test. I find it's useful to look at the group statistics first so that I can really know what the data are telling me, and then look at the independent samples t-test to see if it's significantly different or not. So as a reminder, high scores are a bad thing in this case. So high scores would mean somebody's very anxious. Low scores would mean they're not feeling very anxious. So in looking at the mean scores in post-treatment anxiety, we expected that cognitive behavioral therapy would have lower anxiety scores compared to the waitlist control. It appears that that's the case. Notice the mean score for CBT is around 3.8, and the mean score for the waitlist control is about 7.4. That's probably because I made the data up and was able to make it look just this way. That being said, we know also that we have 10 people in this set of participants and 10 people here for a total of 20 participants. What we'll then take a look at is whether or not this difference between 3.8 and anxiety in the CBT group and 7.4 anxiety in the waitlist control, is that actually a significant difference or not? We don't really know just by looking here. We have to look down at the inferential statistic or the independent samples test. So looking down here to the post-treatment anxiety assessment, we first run into Levine's test for equality of variances. What this is telling us is, have we met the assumption for equality of variance or homogeneity of variance? So this is something that we have to take a look at first before we interpret the t-test. It's really a very simple process, which is that we look to see whether or not we have violated the equality of variance, or whether the variance is significantly different for each group. So the general rule is if there's a significance level of 0.05 or smaller, then we cannot assume equal variance. And then we have to do a corrected t-test, which is actually already done for us, just in case we need it. So our question is the significance of the equality of variances lower than 0.05 or not? In this case, it's not. It's 0.09. What that means for us is that we can assume that the variances in each group are generally equal. That also means that when we're doing our t-test analysis, we use this top row of statistical output to interpret the data. If this were, say, 0.03, then we would assume that the variances are not equal, and we would drop down here to this somewhat corrected t-test that accounts for the differences in variance. So this is good to know so that you're always doing the most accurate analysis. In this case, we're going to now look at the t-test for equality of means, the independent samples t-test, and our main interest is in right here. We have a t-value, the degrees of freedom, and the significance. So first let's address the degrees of freedom. This just is something that lets us know how many data points are varying. And in this case, we had 20 participants, and we have two groups. And so we take the total number of participants, 20, and we subtract the two groups, and then we get a degrees of freedom of 18. And that's something that we report in our output. Our t-value tells us the magnitude of the difference between those two means in a standardized way. So in general, the higher the t-value, the greater the difference between these two means. The significance level tells us the probability. So significance is the same as probability, or p-value. What that means is it tells us the likelihood that we would get this big of a difference in mean scores simply by chance. So looking at the difference that is 3.8 compared to 7.4, with these variances, it is highly unlikely that we would get this big of a difference if we were just randomly pulling any 20 anxiety scores from a group. So the significance level is less than 0.05 for sure. So if our threshold is 0.05 to determine whether we reject the null hypothesis, in this case we definitely reject the null, which means that then we can say that we have support for the alternative hypothesis that cognitive behavioral therapy produces lower anxiety when compared to a waitlist control.